Hello. We're going to talk about types of muscle contraction. And there are two types: isometric, isotonic. Isometric, iso means same, metric means length. For isotonic, again, iso means same, tonic means strength. So we have these two different types of muscle contraction: isometric, isotonic. Graphically, they look completely different. Okay. For these two types of muscle contraction, what we're going to be doing is we're going to have a specific apparatus shown here. In this apparatus or device, we're measuring two things. We're measuring force, and we're also measuring length changes. In the other apparatus that we talked about, the muscle was kept at a fixed length, or it was locked at a fixed length. We can actually measure the change in length. So this is a little rod here that can swivel up and down, and has a little pen on the end, and it's actually attached to a device that I can actually measure length changes. The muscle is suspended in between here, like that. So this device, we can measure both force and we can also measure length changes. And this is how we're going to measure isometric and isotonic changes. Isometric changes, there's no change in length. So what we do is we lock this device from moving, so there'll be no length change. And what an isometric contraction would look like when we measure force, okay, we measure it over time. So this will be force over time, and you get a muscle twitch. So this is isometric contraction. There is no length change because this apparatus is locked. So when we look at length over time, so this is length, and this is force per time. There is no length change because it's isometric, so which means same length. What is important to notice about isometric is by keeping the muscle fixed, the muscle will contract with the maximum force that it can generate. So this is the F max, the maximum force that the muscle can generate for that specific length of muscle. If I change the length of the muscle over here, then you can also change the total force that the muscle can generate. But in this experiment, the muscle will be fixed. So if you alter the length here, you will fix it and measure the total force that can be measured. Okay, this is also called the total isometric force as well up here. Now, let's look at isotonic contractions. Isotonic contractions, we no longer lock that muscle at a fixed length. So we allow that lever to freely move up and down. So as the muscle contracts, this lever will go up. As the muscle relaxes, this lever will come back down. So for the isotonic contraction, we no longer lock this muscle, we allow it to move, and that lever will move up and down. Okay, so the length will change over time. So that lever will go up, and that lever will go down, and the length of the muscle will change. How does that look when you're measuring force? It would look like this. So this is force versus time. And what happens is the muscle will contract, contract, contract until it generates enough force to move whatever object is there. So right now it will be the lever. And then the force will stay the same. So isotonic, same strength. So the force will be the same. And then the muscle will relax over here and not generate any force. So this is an isotonic contraction. It has the same force. What will the length look like? So here's length versus time. Well, let's just draw little lines here so that everything will be to scale. So what will happen when the muscle starts to shorten, this lever will go up and you'll register movement going up. Then the muscle will reach its apex here and then it will start to relax and go back to the original position. So this is how the length will change. So this is length versus time and force versus time for isotonic contraction. Here for isometric is force versus time, length versus time. You can see that the length stays constant and the force has a bell curve. Isotonic contraction, the force increases until the muscle can move the object that it's attached to, and then that force remains constant, and then the force goes back down. So it looks like a tabletop or a plateau on top of that force per time muscle twitch, but the length changes. So these are two important differences between the isotonic and isometric. This is length per time, it's a bell curve, but the force per time is flat. Force per time, bell curve for isometric, the length stays the same. What you should also appreciate within the isotonic contractions, there's different phases within this muscle contraction. Here and here, there is no change in length. Since there's no change in length, and this causes students confusion, these are called the isometric phase. So it's not isometric contraction, it's isometric phase occurring within the isotonic contraction. This portion over here is called the isotonic phase. So there's two different phases. There's a phase where the muscle is generating force and there's no movement here and here. These are called the isometric phase, shown as these slopes here. And the isotonic phase is right here, the plateau part, where you get movement and length changes. So that is isometric change. So that is isometric contraction. Iso, same, metric, length. Isotonic, iso, same, tonic, strength. So inherent within their names, you can actually interpret the graph. Isometric, the length will be the same, you get this bell curve. Isotonic, the force will be plateaued across the top and the length will change. And just to compare these two, if the muscle was not allowed to move, then this graph would become an isometric graph and you'd find that bell-shaped curve. But since the muscle is able to move, you have that plateau and the force to move that object is flat.